Hello. In this video, we will be exploring the relationship between area and perimeter. We will be using the free software program GeoGebra. This is how you spell it right here. To get the full learning experience, you will need to download GeoGebra and work on activities while watching this video. There will be a few moments where I will ask you to pause the video and complete your task, then return to the video to continue our activity together. If you watch this video without downloading the software, you will still learn something, but the concept of this lesson can only be fully grasped if you explore on your own. So go ahead, pause the video, and download GeoGebra. All right, so let's open GeoGebra and get started. This is what the screen will look like when you first open it. We do not need the axes for this activity. So I want you to right-click or press Control-click if you have a Mac. And you see axes selected here. Click that and it will turn them off. If grid is not showing, you do want the grid. So right-click or Control-click and select grid so that your screen looks like this. All right, so here is your first challenge. Can you make a regular lattice polygon with 8 sides? So can you make a regular lattice octagon? What does that mean? Well, a lattice polygon means the side lengths are in consecutive order starting with 1. So for a lattice octagon, it would be side lengths of 1 unit, the next side 2 units, 3 units, 4 units, all the way up to 8 units. And a regular lattice polygon means that all of the sides are perpendicular to their adjacent side. So at every vertex, there should be a 90-degree angle, either interior or exterior. Okay, so I'm going to show you how to make your 8 sides, and you can make them while you watch the video or press pause and come back. So we're going to use this third box right here, and there's a tiny arrow in the bottom right corner. Click that, and it says segment with given length. That's what we want, so click that. Now choose any corner. Let's start at the top here. So we want a corner of our grid. And now it asks what we want our length to be. So let's put 1 and then click OK. Now we want to make another segment, and it's already selected, so we don't have to choose it again. Just click another corner. Click here and put side length of 2. Okay. Click here, side length of 3. Side length of 4. Side length of 5. Side length of 6. Side length of 7. And side length of 8. Okay, so now we want to use these segments to make an enclosed polygon. Before you can start moving them, you have to click this box here, which says Move. And now you'll be able to move the segments around. You cannot click in the middle. It won't let you do that. But it wants you to click here on the first endpoint of each segment that has a dark blue color. So you can click it and slide it anywhere you want. And then I can click this one over here. Now, if I want to change the direction of this, I use the light blue, and then I can swing it down. So now I have a 90-degree angle. And then I can move this one over here, and this one I would have to shift down or up because it has to be 2 separate segments. So now this is at a 90-degree exterior angle here. Okay, so give it your best shot. There are many different ways to make a regular lattice octagon, but it's also very challenging. So it might take you a little while. Just pause the video, come back, and we'll talk about one possible solution and how to check your own answer. All right, so here's one possibility of a regular lattice octagon. Yours will probably look different. There are several hundred possibilities, actually. I found that surprising because it was challenging just to find this one. But there are many. So you probably have a different lattice, a regular lattice octagon on your screen. But let's look at how we can check whichever one we've made. So we want to make sure that we have 8 sides. 1, 2, 3, 4, 5, 6, 7, 8. And we want to make sure that every vertex has a 90-degree angle, either interior or exterior. So here we have 90 degrees, 90 degrees. This angle here has a 90-degree exterior, okay? So that meets the criteria. 90 degrees interior, 90 degrees, 90. Okay, this one also has a 90-degree exterior. That works. 90 degrees and 90 degrees. Okay, so this is a regular lattice octagon. Hopefully yours met this criteria, so you did successfully complete the first challenge. Okay, so here's the second challenge, and this one is a lot more challenging, but I'm sure you can figure it out. So, can you figure out what configuration the sides need to be in to get the maximum area? So, how can we check the area of the one we already have? First, we need to make it a polygon. So we're going to go around the perimeter to make it a polygon. And then we can go up here to the measure tool and select area and click inside. So the area of this regular lattice octagon is 55.05. Now I look at this and I think I can probably do better. It could probably be like a little wider out here, like the polygon could be opened more up here instead of this being wasted space. So I'm going to try again and see if I can get the maximum area possible. So what I would need to do next is to go up to File at the top, Edit, and then click Undo. So it'll undo the area, and then Edit, Undo, making that a polygon. Now you can move all your sides again. So before you come back to this video to see the answer, ask yourself, how do you know you have found the lattice octagon with the largest area possible? How would you justify your reasoning? This will take more than finding several lattice octagon configurations and stopping with the one with the largest area. It's about finding a pattern. So pay close attention to any patterns you see when you make different lattice octagons and how the positioning of the sides affects the area. Use inductive reasoning to find a general rule so that you can maximize the pattern to find the maximum area. All right, so go ahead and pause the video, and it might take you a while, but I'm sure you can figure it out. Okay, so here we're going to figure this out together. We're going to go step by step. Hopefully you were able to find what you think was the maximum area. Think about what your justification is and look and see if it matches what I'm going to explain here. So the first thought is maybe when you were finding the possible configuration before, you realize that it's kind of like there's a frame here. If you imagined it like a square shape, and then you kind of were pushing the corners in. So let's start by thinking, what is the maximum area that our segments could make, even if it wasn't an 8-sided object? So forget about it being 8 sides. If we just put the segments in any position at all to get the maximum area, what would that look like? Well, if we could move this out here and get this whole area, Okay, so let's try that. If we could move this out here and move this up here, well, that just gave us a whole bunch more area, didn't it? And if we could move this as well, we would do the same thing. Okay, so this is our first step. We want to figure out how to make the largest square we can. Well, a square would be larger than a rectangle if we could maximize our sides. So let's look at what our sides are right now. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, well, I just happened to work out for this one. But if yours wasn't already 9, how might you have figured that out? Well, you could add up the perimeter, add up the line segments of all of your, the lengths of all of your line segments. So we would have 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. And that's going to give us 9 times 4, 36. So if we wanted to make a square, what would that be? That would be 36 divided by 4, which is 9. So each side needs to be 9. And then you put your segments so that each side has a length of 9, making it a square. Now, we can't leave it like this because we need to have 8 separate sides. And right now we only have 4. So we either can pull the segment away or push it in. But if we pulled it away, we wouldn't have a long enough line segment to reach it. So pushing it in is the only option we have. But we want to push it in as little as possible. So when I had these line segments here and we pushed these in, that took out a huge chunk. We want to take out as small of chunks as possible. So what line segments could we put in the corners? The smallest possible ones. So our smallest ones that would make corners could be 1, 2, 3, and 4. So we think, how could 1, 2, 3, and 4 be positioned? So right here I've got this, 1 and 2. Could 3 and 4 be over here? Okay, let's see. Got 3. And 1, 2, 3, 4. Okay, we got 4 already there. Okay, so now let's move them in. I'm gonna push that one down here, and we're gonna slide this one over there. And then we're gonna push this one over here and slide this one up there. Okay, well that looks pretty good. Okay, let's see what our area is for this. So we need to make this a polygon. Okay, and let's measure that area. So area, click in here, that's 67.05. Well, that's better than what I had before. But let's look at it for a second. We want to be confident. We understand our justification so far. We want the smallest segments possible. We have to use 1, 2, 3, and 4. But that corner here looks pretty big. Could we make that any smaller? What if we did 1 and 4 and 2 and 3 together? Let's try that. Okay, so what would that look like? Okay, so if this is our side with 4 and this is our side with 1, then we just need to slide them this way. Here. There we go. And slide this one up here. Move our 4 here. There we go. Now we've got our 1 and 4 beside each other, and we just need to straighten this up over here. And let's see, we've got our 1 and 4. So we need our 2 and 3, so we got to slide these as well. There we go. Okay. So this is our only other possible combination. So let's give this a try. Move in this corner. All right, okay. That looks like it has a larger area, but let's double check. So we'll make this a polygon. Okay, and then we want the area. And it is. Okay, 71 is the maximum area that you can get, and this is the configuration. So if this is what you got, then your answer was correct. If not, just think about the reasoning we did here, go back and work on it a little bit more and see if you can figure out how we got this answer. If you can follow those steps and the reasoning and see how we can be confident that this is the maximum area we can get for a regular lattice octagon.